Okay, we're going to get started. Good afternoon, everyone. Welcome to the i4Energy's seminar series. My name is Gaiman Yi. I'm the Technical Director for the i4Energy Center. It's my pleasure today to introduce today's speaker, Mark Martinez from Southern California Edison. Mark is a Senior Project Manager in the Demand Response Program at SCE. He is currently responsible for facilitating SCE's regulatory policy for energy efficiency demand response program integration and coordinating DR interaction for state and federal agencies. At SCE's, he helped develop the SCE Energy Orb, which I think he's going to talk a little about that today, and also the SCE Energy Smart Thermostat. Mark's talk today is getting customers to respond to California energy policies, nature or nurture. Welcome, Mark.
Thank you, Gaiman. Before I get started, I want to give a thank you to Paul Wright, who I met at some of the very early development work that we were collaborating with, as well as Gaiman. I've worked on technical advisory committees with him. And then for inviting me up here, Gary Baldwin, and of course my good friend Ron Hoffman, who's been an advisor and been in the business for some time. Southern California Edison is the other utility down south. And we have, let me give you a little description of that. We are located sort of in half the state, 50,000 square miles, everything from sand on the beach to sand in the desert. So it's a lot of different climate areas. What's interesting about our utility is that it is, does not include Los Angeles. So there's 1 million customers in Los Angeles, which is the biggest municipal, city-owned utility. We're an investor-owned utility. So Los Angeles is not covered by California regulations traditionally. They're a city. They do pretty much what they want to do. Whereas Southern California Edison has a lot of regulatory oversight and so forth. So it's important to understand the distinctions. City of Anaheim, where Disneyland is its own city utility. And you'll find a lot of those different places, like Sacramento as well, different. So you need to know a little bit about the lay of the land. Now, Edison's been around for 100 years. And the basic traditional model of selling electricity was that, you know, we provide it and you buy it. And as electrification came to California, which actually started out in the agricultural industry, appliances after World War II, people started doing things. What was the biggest thing that happened in the Depression? People couldn't afford their household servants anymore. People couldn't afford drivers, maids, and things like that. So after the Depression, you had appliances like washing machines. You know, people were actually doing their own wash as opposed to having the housekeeper do it. So with that came the need for more and more electricity, and in the 1980s we built nuclear power plants, we had gas plants. But in the 1979 OPEC oil crisis and the early 80s, we actually ran out of electricity. It got to the point where we couldn't build fast enough. So we started these conservation programs. And this is from 1982, which was a while back. And it basically said, you know, could you do us a favor and not use electricity in the middle of the day? Because we can't make enough of it. So people actually were, you know, what they call shifting their usage. Now, there weren't price signals. There wasn't any ramification. It was pretty much a goodwill thing. And then we had ads in the paper that talked about the fact that we're running short of power. So those were altruistic messages. Now, there's a big difference between 1982 and 2009, where we're at now. There's a lot more people in the state, and we've built a lot more power plants. But there is a policy in the state now that has always dealt with conservation. And California is one of the most unique states in the entire country. And the difference is this, is that for my company, it doesn't matter how much electricity I sell. I will always still make a constant profit. That's not the same for Texas or for Florida or other states like that. So they don't really believe in conservation that much because it's not a good business model. But if you noticed here, back in 1982, about the same time those ads were coming out, the utilities in California were allowed to decouple their sales from their profits. So, you know, the basic business model is that the more product you sell, the more profit you make. Well, our profit is not dependent on the number of sales of electricity we manage. It's basically developed on the capital asset, power plants, wires, transformers, things like that. The more we build, the more asset we have, and that's our profit base. So that's a very important signal, because what that means is that employees like myself don't have to promote our product. It's the Philip Morris syndrome, where I'm telling you not to buy my product. You know, don't smoke my cigarettes even though I'm selling you cigarettes. Don't buy our electricity. But it's not so much about not buying it, it's about don't waste it, use it wisely, and use it at the right time. So we've had a very long history of providing incentives, of marketing our programs, and you can see during the energy crisis, there was a lot of investment. And now, finally, instead of reacting to short-term needs, one crisis after the other, the state has developed a long-term plan to build in efficiency and to build in the right signals for customers so that we can have a better future. Now, over those years, we have avoided building lots and lots of power plants. And the hardest thing for people to understand is what you don't have. We all understand what we have, and we all understand what was taken away from us. But we don't really understand what could have been. And you can see here, we have avoided building or buying all of this energy as a result of the leadership of the state of California, in that California would not allow the imports of inefficient appliances, like refrigerators and water heaters, number one. The second thing is that California won't allow inefficient buildings. We have building codes, Title 24. This building that was built in accordance with state standards is more efficient than most other buildings across the country. And the third thing is that once you decouple the profits from sales, then utilities have an incentive to go out and make sort of unsell their product. And that has really made a difference here. And so compared to the rest of the United States, per capita, meaning for every person that is in that state, the usage across the country has gone up. Whereas in California, it's remained pretty much the same. Even though there's 35 million people in the state, the amount of energy they use is pretty much the same as it was back in 1974. It's amazing. Even though we have lots more stuff, okay? Microwaves, bread makers, big screen TVs, you name it. The energy intensity has gone up, but it's more efficient now, just like the number of cars. So what we are doing now is replacing power generation with customer assets. We've had, you know, for example, I believe it's Indiana, 95% of their energy comes from coal. Coal's very cheap. In China, they're building a coal plant every month. It's a very inexpensive fuel, but it's a very dirty fuel. A lot of GHG comes from coal. Nuclear plants don't generate atmospheric pollution, but you can't build them anymore because of a lot of restrictions. Combined cycle are those plants you see out by Morro Bay and by the beach with the big plumes of steam. Those burn natural gas. The more people you have, the more you need of those type of systems. And then you have your combustion turbine. This is a little small unit that you usually see over in industrial parks, and they're about 50 megawatts in size. And you put those strategically. They're very expensive, but they are what you need in a pinch. So that's all of the construction. But you can replace it by cutting back on the usage, okay? By trimming back through rebates, programmable thermostats, and then on the hottest day of the year, in 2006, I believe it was July 25th, we ran out of power in Southern California. We didn't have any more. We forecasted the next day that we were going to be about 1,000 megawatts short. That's an entire nuclear power plant. So what we did, we activated load control. We turned off air conditioners. We asked businesses to shed load. And it was July 21st, sorry. And that's when the red line, which is the usage, gets close to the green line, which is how much power you have. Because the state only has so much power. It's like only so much water. we can't control the population. They are going to use their air conditioners when they need it because they built that house and they want to use it. So we can ask for voluntary conservation, but sometimes it just doesn't reach it. So right there was what our forecast was, day ahead at 47,000 megawatts. In actuality, we peaked up at 49,000 megawatts, but that's only because we shed. Okay? And this is the impact. The red line would have been, again, that concept, where you would have been as opposed to what you are. So the actual load at Edison of all 4.5 million customers was that nice green line. But it's only because that we were able to reduce about 400 megawatts through these control programs. That's what we like to call, and there's a fellow over here at Lawrence Berkeley named Alan Meyer, he calls it saving energy in a hurry. Okay? We all want to conserve energy. We all want to be efficient. But every once in a while, there's a drought in Brazil, or there's a nuclear plant shut down in Tokyo, or in Juneau, Alaska, there's a landslide that cuts off the power lines, and you got to shut down energy in a hurry. So we always have that in our back pocket. So, state of California says, you know, this is fine and dandy. We've been fussing about all these different things, but the state's still growing. The economy is good with temporary mishaps. How are we going to have the long-term vision? And the long-term vision is, you know, we got to stop building power plants. It's got to be efficiency, and it has to be saving energy in a hurry programs. And then, if we do build a power, that's our number one priority. The second priority is if we're going to build a power plant, let's do it with renewables because they're cleaner. It may not be the cheapest, but it's the right thing to do, and it's less of a pollutant. And then you have, if you're going to do generation, let's do generation the right way with efficiency. And then the fourth priority is that, you know, you don't put a bunch of windmills in downtown Berkeley. They're usually out in the Tehachapi Mountains or at the Altamont Pass. You need a transmission line to get them over. And that's the other priority as well. So they developed the Energy Action Plan after the energy crisis, and that plan was recently updated, and it's available at California Energy Efficiency, and that is the strategic vision and policy. Now, everything that comes down to tactics and rules and laws usually develops at the beginning as a policy. And that's what I'm going to talk about now is how do we translate and how does a utility like Southern California Edison convert the state's policies into actual programs and tactics? So we have the Energy Action Plan, which is the first policy. There are the Global Warming Acts, GHG. There are rules and laws about reducing our carbon footprint. And there seems to be, you know, a consensus about that. And even to make these programs even more effective, California regulators now, instead of just letting us earn profit on our assets, for all the kilowatt hours that we save, we can earn a profit on that too. It's called the earnings mechanism. So these types of things, you know, it's the loading order. Energy efficiency demand response first, the renewables next, distributed generation, okay, and then fossil fueled. Last order. We got to get all this stuff done first. Doesn't mean we'll never build another gas power plant on the coast, but we got to get through all of these as a priority first. Now, what's in it for the utility? Well, let's look at what we've got going here, which are our generating stations and our transmission lines, okay? We have the ability to use different types of fuels. We have the largest renewable portfolio at Southern California Edison, so we're buying lots of renewable power. But we can use water, we can use wind, natural gas, lots of different things. Okay, and it's important that the assets that we have for transmission lines, they do take a while, but we can site them effectively. Okay? However, our infrastructure is aging. You know, after you've been a utility for over 100 years, a lot of wires and power poles and things get old. So there's a constant need to upgrade these things. So with the energy efficiency and the demand response as programs, okay, and this new thing that's coming out called Edison Smart Connect, and I'll talk about that, okay, it's all linked to customers. Now, before it was all about the utility infrastructure, the power plants and so forth. Customers weren't mentioned before. But now it's about the customers. And they become a part of the supply chain. And that's going to be important now. This graph is a little busy, but what it shows you is that, as the growth goes up, okay, you're able to bring down, let me bring that gap there. You can reduce your resources. See, the one thing the one charter that we have with utility is to maintain the power reserves and to be able to supply power and not really run out of electricity. Customers don't understand that. They say, I'm paying my bill, why don't you have enough power? So it's now with the new loading order, and this is the state policy, and it may be federal policy soon, you really have to work on the customer side of things. So we're talking about 2016 being able to come up with hundreds, if not over 1,000 megawatts of this, what Amory Lovins coined the negawatt. It's not a megawatt, but it's a negawatt because it's a non-watt. Can't measure it because it doesn't exist. You can only estimate it. So now we bring in the economists and statisticians, okay? In the old days, it was all about power engineering. It was about construction and so forth. Now that you're dealing with sort of negative power, and now that you're dealing with things that they're intangibles, you have to bring in the intangible experts, the economists, social scientists, and so forth. That adds up to about 2,800 megawatts of negawatts that we have to come up with. So what's our philosophy and what's our big plan, our vision? Okay? Now the vision is what I call the nature of things. And the nature of things is what we build and what assets we have. And you can see that it's renewable generation and a smart grid, and then a smart connect, which connects to the home and it connects to these electric vehicles and all sorts of other things too. Because now our customers are not just buying big screen TVs, they're putting solar panels, they're getting electric plug-in hybrids, they're doing lots of things. We have to be smart. We used to ignore that. We say, it is what it is. We kind of forecast and we kind of look at trends. In the 1980s, there were a lot of water beds with electric heaters on them, that 200 watts. And thought, is that going to be a trend? Well, they all went away. Okay? But they were replaced with microwaves, gaming systems, computers and laptops, and satellite boxes that have more than doubled the energy in homes. People wonder, why am I still getting a bill when everything's off? Well, it's those vampire loads, as they'd like to say, things that are still running. So this is all going to connect up, that the grid is going to know what's happening in the home. Now, Smart Connect is sort of a fancy word for our metering system. And traditionally, for 100 years, meters were not very smart. They knew how much energy was going through them, but they didn't know what time of day it was, and they didn't know when the energy was being used. They just knew there was so much of it, like your water meter. You look at it, the numbers are different every time you look at it. With the new meters, I will know, and you will know, when usage is being made, being consumed, and that way we can make the electricity to match the usage. And that's very important, because now the whole system has to be smart. And the other thing that's very important too is that we will know when the power is out, the outage communications. So now there's a concerted effort to not only provide better service, but also better information. That's a key word, information. Okay? The Smart Connect is connecting the customer to the utility and the utility to the customer, so that they both now have information, that the customer will know who is out, and the utility will know who is out. So these meters didn't exist 2 or 3 years ago. We've developed these new meters, sort of like we put out the specification. We said, industry, this is what we're looking for. And the industry didn't make it, and so we put out to bid and came up with lots of different things. This is a meter that will actually communicate to your appliances using Zigbee or some other form. Okay? The meter will also know what time your energy is being used. The meter may even talk to Google or Microsoft. So you can go on your website. There's lots of different features that are coming on here. The meter will enable the collection of information. So you can look on your computer screen or on your Apple phone application and know that somebody just turned on the air conditioner today at home. Okay? Old meters don't do that. Now, the question is, well, like, does anybody care about that? Well, you got to remember the other policy about California is that people, what happened when gas prices went to $4 a gallon? Okay? It's called price responsiveness. This is where the economist comes in. The economists will wag their finger and say, when you make the prices high enough, people will make a change of behavior. So now we're trying to affect behavior by either telling people that there's a lot of energy there or it's going to be really expensive. So when gas was $4 a gallon, my commute to work all of a sudden went from so many dollars to a lot more dollars. So people made changing of behavior a way of life. They either stopped driving, they rode their bike, or they bought a Prius or something to that effect. So there is a lot of functionality with these smart meters. And from a mechanical engineering perspective, this is a very big change. The meter hasn't changed in 100 years. You know, we talk about you know, the rule about technology changing all the time. It's like computers, you know, from 2002. My gosh, we're talking really old school. Well, these meters haven't changed since the 1940s or 50s. And so now we have a whole new technology where it will be computing, it'll understand, it'll have LAN communications, and have a lot of security. And, you know, it's interesting is that because we came up this technology adoption curve where there have always been meters that were sort of like new tech, but they weren't smart and they didn't do all these neat features. With the new meters, we have really gone up to this leapfrog effect here. And this is called from automatic meter reading. There were meters that did talk, but so we wouldn't have to use meter readers. But now we have automated meter infrastructure. So now the entire network is connected. And later on, there'll be applications where you can talk to the meters and application for WiMAX and broadband and so forth. So this is our roadmap. Now that we're armed with these new meters that'll do anything and everything, now we can do all sorts of neat stuff. Okay? It's no longer just building power plants and putting out newspaper ads for conservation. Now we can file new tariffs and new rates. How about an electricity rate that is more expensive during the middle of the day and really cheap at night? That'd be cool because what it will do is tell you don't run your dishwasher during the day, run it at nighttime. It's cheaper, but then you need the information structure. So we're going to have these new types of rates, new thermostats. You know, wouldn't it be great for the thermostat to know what time of day it is and when the price is right? Wouldn't it be great for your refrigerator not to make ice when it's not supposed to? And then, of course, there's a big leap here to educate people. Rather than just take the afternoon off, we want your appliances now to be knowledgeable about the pricing and so forth. And that's our roadmap for the next 3 years until we get up to our 5.3 million meters. Now, PG&E is doing the same thing. They're doing a very similar process with their smart rate and smart meter program. Okay? This is where we're coming from. But what about electricity rates? Let's talk about that. Let's look at a trash rate let's look at, better yet, let's look at cell phone rates. In the early days, cell phones were charging by the minute. And people were kind of like, you know, being mindful of that and revolting against that. So then eventually, cell phones went to flat rates. Trash rates have always been flat. You know, you get a certain amount for a certain amount of trash and so forth. But the problem with electricity is that it's instantaneous. All of a sudden, if a power line goes down in Washington or Oregon, electricity gets really expensive really fast. And I need people to react really fast. I just can't have them using electricity willy-nilly. I need to conserve right now. So I need to send a price signal and tell them, please, conserve, save energy in a hurry. So right now, most of you are on either a seasonal rate or a tier rate. And the seasonal rate says, you know, you pay more in the summer than you do in the winter, or you pay more for the more you use, okay, for consumption. But what we're going to will be time of use rates and critical peak pricing rates, and then real-time pricing rates, perhaps. And it's very similar to people like the stock market. Do you want a nice, safe mutual fund, or do you want to invest in high-tech equity? Okay? So there's a risk factor. So a lot of customers say, you know what, I just want to stay with an easy rate. Okay? Well, you're going to pay more money for the easy rate, just like a mutual fund won't give you as much return. And then these folks up here are these industrial customers. Usually it's the people that are really smart that know how to do this. These programs are very popular with large industrial customers because they track this stuff all the time. Walmart is one of the biggest players in the energy markets. They have all of their stores wired, they have a big trading desk, and they keep track of things. You had a question? These types of meters will be available to all, these types of rates will be available depending on how the rate designs are. But right now they're available mostly to large customers because large customers have the smart meters already. And this is a chicken and egg thing. You can't have the smart rate without the smart reader. So that's why they're trying to deploy these. Okay, and you got to remember, going back to the state policy, is to get customers really involved with the dynamics. So this is an example of critical peak pricing. Now, I don't know if a lot of you know this, but next year, all large customers in PG&E territory this will be a mandatory rate, unless they want to go back to a safe rate. But this will be, and in San Diego, Gas and Electric, this has already been deployed. This month, we are deploying this rate, and next year PG&E will be deploying this rate. And what does this mean? Well, this is the price of electricity for a large commercial customer or industrial. This is the way it is today. Goes up during the day and down at night. Okay? And what is happening in San Diego, this will happen this summer, is that on certain days when there is a power shortage or the wholesale price goes up, the actual price of electricity goes up to 30 cents, sometimes 60 cents, sometimes $1. So that's like, that's not fair. Why are they doing that to me? Well, that's the price signal that the economist says will get you to reduce. Now, you have to be aware of that change, and wouldn't it be cool if your building was smart enough to know that's what was happening? So you don't have to run around and do that. That's called smart technology. So there's a combination of two things going here, is that the pricing of electricity in California is going to go this route. That's a fait accompli. Okay? What will technology do to deliver customers to minimize their costs? Let me go back. That's the stick. In other words, expensive. Do something about it. Okay? In the city of Anaheim, which is, a kinder, gentler place, they decided, let's use the carrot approach. Instead of getting customers to give them a high price, let's do this. Let's give them a rebate. So on a critical day, if you don't do anything, you still pay the 10 cents. But if you do something on a critical day, okay, well, actually you still pay the 18 cents. That's the 18 cents there. But on a critical day, if you reduce your usage by half, I'll double your money. In other words, you get to save because you didn't buy anything, but I'll also give you a credit for the energy you didn't use. So that's called the peak time rebate. And it's an interesting approach. Now, if there's any social scientists in the room, there's a number of behavioral factors going in here. Okay? There's gaming theory, there is the stick and the carrot, loss aversion. I mean, how do people react to these types of things? And that's a very important concept. It takes a lot of education and a lot of training to get people to respond to these programs. For years, we have just been paying our electric bill. We look at it once a month, we see, oh, here it is, another $50, or I better do something next month to change that. And then the price changes, and it's not really something on our minds. Electricity is becoming a dynamic commodity. And in the next 10 years, the vision is that you will need to track it, or you'll need something to track it for you so that you can reduce your costs. So this is our simple engagement, which is now the nurture principle. Okay, we've got enough technology out there. Now do we need to engage our customers in education and to change their attitudes and then to change their behavior through a two-way dialogue. And that's going to be with the metering system. So once you've got a gateway into the home or a website or something, you can now interact, and there's lots of ways to interact. I mean, this is stuff that I think is already out of date, even though it's just last year. I mean, we're not talking about iPhone applications here. We're talking about simple thermostats. There's a lot of ways to interact. General Electric just came out with the fact that they're going to be producing smart appliances now. Okay? That's going to be a product line. The electric vehicles will all be hooked up to the meters. They'll all know what's going on. Who knows what's going to happen, but there's a lot of predictions because you're going to be able to have a lot of information for now smaller customers. Large customers have always had this information, but they didn't really do much with it because there's really not they can do day to day except to manage their costs. But residential customers, it's the 80-20 rule. 20% of our customers use 80% of the energy. Okay? The residential customers are responsible for a lot, and they're now going to get this. So we have to do a lot of communication with them. Here are all the different ways. This has been going on for 20 years at least. Customers, in the absence of having information from their meter, have gotten it themselves. They put devices in their home. You can go to Home Depot or Costco and buy little monitors. They'll tell you how much energy you're using. Okay? Well, that'll soon be available through different ways, through the meter, through applications and things like that. And that information, gives you endless possibilities, especially with the fact that you now have solar panels on your roof. So there is technology that is developed, but it needs to be developed further. And then there's behavior models that need to be worked on even more so. And the secret here is information. Sometimes you can have too much of it. Do I really want to know how much energy my house is using every day? Or do I really want exception reporting? A lot of our customers have said, don't bother me with all this stuff. I got 2-3 jobs already. Just let me know when I'm in trouble. Okay? So we need bots. We need types of mods. We need something that'll give exception reporting. And there's a lot of back-end stuff. Clicking on the web pages is not going to do it. It's going to have to be real-time, instantaneous information that gets you out there. Okay? And there are lots of ideas. There's lots of different ways. It can be Zigbee. It can be control applications. There's home plug. There's no end of technologies that have been around for some time. I mean, smart houses have been around for a while. But now the smart houses are going to have to know, all right, in addition to, calling 1-800-SMART-HOUSE and turning on the spa before I get home, it's also going to have to know when the price is too high or too low, be able to do the right thing. Okay? And one of the things that's important to know is that, there is a big vision out there, but it's driven by policy and it's driven by the prices, the critical peak pricing, the peak demand. Those will be here in PG&E when all those meters are plugged in. Then you will be getting a letter in the mail. Congratulations. You are now eligible for PG&E's smart rate. And I guarantee you that smart rate price will change every day, every week, sometimes all the time. And you're either going to have to run around and figure it out or take a look at some of the technologies that are available. Yes? Can they get a rebate? Well, that's a good thing because currently the way the rebate structure is set up is for efficiency. For example, Energy Star labeled appliances are pretty efficient and they will reduce your energy cost, for an additional price and so forth. But maybe there will be, for example, there's a thermostat at Home Depot called RITEMP, and that thermostat probably when all the meters are installed, we'll have a little sticker on it that says, if you buy this thermostat, you'll get $10 off it because it is compatible with the PG&E Smart Rate program. Okay? And the same thing like compact fluorescents. Compact fluorescents are very inexpensive because they're subsidized by the utility. So you have to keep the eye out, and that's one of the things that we're looking at, is that when all this technology is installed, then vendors, you got to remember, GE and Westinghouse, California is just a niche market. They sell to the United States, to Europe, to South America, and Pacific Rim. So, 10,000, 20,000 washing machines, not that big of a deal to them. But they are starting to look at this sort of thing. Now, with the price signals, with the rates, with all the information, sometimes that's too much overload. So, several years ago, Edison and PG&E said, you know what? I mean, everybody's got their BlackBerry, their iPhone, they're getting paged, they're getting emailed. It's all gets lost, the information. So we did an experiment. And we tried out something that was available from, of all places, Brookstone stores, okay? It was called the Orb. And we simply just took this little device, which is a paging lamp, and we put it in people's homes, and we put it in people's businesses. And we said, when the orb is green, everything's cool. Your prices are okay. But when that thing starts flashing red, that means that tomorrow's a critical day. Okay? And we took that orb, and then we also had another group of customers, and we gave them emails and pages and phone calls and everything else. Okay? Now, what if all of a sudden the lights in this room turned green? Okay? Well, you would notice it, or there'd be a subtle change. It's basically called ambient technology. It's like when you drive your car. You notice the wheel's out of alignment, something's wrong, you don't know what it is. And we found that these customers responded twice as much to this little glowing ball than they did to all of the emails and pages and things like that. And the difference is because it wasn't a more effective communication technology. It wasn't high tech. It didn't have all these RSS feeds. It was just basically a lamp changing color. Okay? And that's what we call the nudge. Sometimes it's just a nudge for a customer. This was installed in a restaurant. And when the ball's blue and everything's fine, you don't really notice it, you're doing your business, doing different things. When it starts flashing red, you take a look at it and you go, what is that? I remember, yeah, tomorrow's a critical day. And so they started turning lights off and doing different things. Okay? PG&E has over 1,000 of these with their commercial customers. We have 800. And they're used in Chicago. They're used in New York. And it's not a high-tech device. It's just a ball that changes color. So sometimes the simplest technology is the most effective. And that covers my talk for today.
Thank you, Bart. We can open for questions.
So two questions. One, the fact that you start changing the behavior of the customer.
Yes, changing behavior.
And you're pushing them that they will be the one that they have to pay the price in different ways. Either you adapt to the technology, either you go and buy the things. This is your responsibility. It's not my responsibility. We do that one, but this is your responsibility. What is the consumer advocate they're going to tell you? Still you're going to just pushing everything to us rather than you.
Right. It is definitely, there's an equity issue about what's fair and what needs to be, whose responsibility is which. There is a policy in the state to ensure that we do follow the different loading orders, okay? Energy efficiency and demand response are programs that are available. But the bottom line is not so much a responsibility for the customer to participate, it's an opportunity for them to reduce their costs on their bills. And that's the number one driver.
So the second one, to follow up on that one, so if you look at, for example, oil industry, as you said, example of the price goes up and so forth, it's not really driven by the customer. So you use, still you'll use, the prices stay the same. And so you again shifting the things from the day to the afternoon, so again that would be the same stock market. So if you look at these two, again, these are the two failed type of the scenario that happened. We see it either in the oil industry or we're seeing it in the stock market. What do we learn from that we don't repeat the same mistake?
Well, that's a very good point because a lot of these programs were precedented by pilot programs to see which were the right designs were to do. The critical peak pricing rate over the entire year is the same as the regular time of use rate. In other words, if you had two customers doing the exact same things, they would have exactly the same bills. But the critical peak pricing customer, if they take action they can actually save money with their bill over the long term because they get a discount. So a lot of the rates are what they call revenue neutral. In other words, there's no harm to people for not taking the rate, and that's the equity issue. But the things that we do learn is that how do customers respond effectively? What is their behavioral choices? We always think of customers as the rational consumer, you know, the person that's going to make the rational choice. You give them all the right prices. And sometimes there are emotional, well, a lot of times there are emotional content to their decision. So we need to deal with all those factors. Yes? You pick them.
The follow-up question, the orb experiment is very interesting. The comparison of the orb to more complicated forms of information. You well know that the idea of in-home displays is now all the rage in certain quarters. People are going to use it all as information and use less energy. Can you say something about the research that you're doing now on how to provide information in effective ways to consumers, whether social science, economics, this sort of thing?
Yes. One of the things that we have been challenged with is that information interfaces are constantly changing. Okay? 2 years ago, when I would have said, well, we need an iPhone app, you know, they would say, what? You know, it's like there's, you know, the traditional model for a long time has been go to the web page and review your usage. Well, that's not really something that is dynamic enough for folks. The exception reporting that we talked about. I mean, people, you know, get a lot of exception, you know, people get texting, lots of different things. So currently, we sort of reverted back to the original concept of at least providing the information, make it available for people. What they found in Chicago is that a lot of income qualified customers did not have access to internet. So they had a recording that you could dial 1-800 and hear the electricity prices on the phone. And they made it available. So they knew these people weren't going to get it on the internet or on their phones, but they just gave them a phone number. Okay?
What institution in Chicago?
This is the, let's see here, ComEd did an experiment. And it was a real-time pricing experiment. So if you Google ComEd, real-time pricing, you'll find their thing. Yes?
So on my air conditioner, I have a controller that I can program, you know, time and what time to cool and what temperature and stuff like that. When you put the smart meter, if you have a controller that you can program to turn on and turn on devices, or you have to get it from some other private.
Well, you wouldn't have to replace the air conditioner because the air conditioner, you know, the what I would call the heavy equipment aspect of it.
No, the question was when you install the smart meter, it would be nice to have a controller that you could program with different devices.
Oh yeah, well we already know that thermostat companies already make these. Okay, so you can, you know, depending on the meter. One of the things is about standards. You know, USB is a common standard for all computers. You've got, you know, mice, you've got lamps, you've got all sorts of things that will go into the USB port. So we need to find that common interface, and it's being worked on today. So when everybody has meters, then they'll figure out how to hook those up.
You used the language, but it wasn't Java. Why did you use Java? Java's original intent was for you to be able to talk to your appliances. And so what language do you use for computers?
Well, it's not so much the language, it's the application layer and the short-term haul for it's Zigbee, okay? And so Zigbee is the communications protocol. It's kind of like, compare it to Bluetooth or Z-Wave or things like that, similar. And the reason for that is because of the application needs and so forth. But my guess is that, you know, there is no exclusive short-haul communications protocol. There will be lots of different types that come out.
So many questions. Gentlemen in blue?
You're talking about instantaneous information about price fluctuations. The two questions come to it. Number one, either residential or commercial, that the price all of a sudden jumps 60% to 100%. What does that help me in real time? I mean, I'm not going to stop the production on it, or I'm not going to run to my washing machine and plug it up. That's number one. And then where's the incentive for the
Okay, that's a good question because those exemplify two different aspects of pricing. The first one is called price responsiveness. Now in Georgia, there are large companies that are on hourly pricing, meaning the price of electricity changes every day. And there's a lot of people on that program, and there's a lot of manufacturing in Georgia, I think paper mills and things like this. So why do they join this program? You can't shut off a mill every hour. Well, the reason they join it is because 90% of the time, the prices are very low. Whereas if you're on a hedged price, which is like a regular, ordinary fixed price, you're paying more than the wholesale price most of the time. So the real-time pricing person, they're going to say, you know what, I want to take advantage of that group discount. So I'm going to go on this real-time pricing program, and if it gets really expensive, I can still handle it because, you know what, for 99% of the hours all year long, I'm paying wholesale values. So that's the difference in that. Now, I don't expect residential customers to really get there, but it's already there in commercial customers because they like paying these cheap prices, wholesale, okay? So that's the reason why people do that sort of thing. I think it's probably not the kind of thing that is suitable for smaller customers, and that's why we have fixed prices that are 13 cents all day long, okay? Even though the price may be cheap at night, you know, sometimes the price goes down to zero at night. It's like, you know, there's all this water flowing and nobody can buy it, so they just give it away. It's amazing what happens on the wholesale market. But your price is still 14 cents, though, at night, because you're not part of that real time. Well, the smart customer will get into that market and do that. The second thing is reliability. When a power line goes down in Oregon, I've lost 1,200 megawatts, okay? I need to fire something up real fast, or I need to do something. So if I can't get a power plant running fast enough, then maybe there's a large electric furnace that's over in, you know, Vallejo or someplace, I don't know. And you know what? They're hooked up to you, and you send them a signal and you said, hey, I need you to drop load now. And they just simply turn the furnace off. Now, that giant vat of molten aluminum is not going to get cold in any time soon. So they just simply unplug the electrical heaters, and they just drop 500 megawatts. And you do a few of those, and pretty soon you've now brought your load down, and you can meet the demand. So you're okay. And then after a while, it goes back up again. So that's called the reliability system, and utilities have been doing that for a long time. It's a good reason to do that. Now, it's difficult for customers to run around and push things off, okay? But what if all the thermostats were hooked up to that, and it was a hot day, and instead of cooling your house at 74 degrees, the thermostats in a second just all went to 76 degrees. Well, the air conditioner would turn off just like that. We could save 500 megawatts for about 15 minutes, and then the air conditioners would slowly come back on again. But it's a great way. We've done it. We've experimented with that. We would drop a ton of load, and because that radio signal is instantaneous, or that broadband signal. So these are little ways, you know, and it's just like dimming the lights 10%, or just adjusting the temperature a little bit. It's what Art Rosenfold calls, you know, the small adjustment. Rather than shut everything off and lose service and cause billions of dollars of heartache for economy, let's just adjust things a little bit. Back off on the throttle, and it can be done automatically. Gentlemen, young.
I have a question. That's the other option. I mean, you mentioned in your slide that your smart meter has 200 kilowatts of power to supply to every home. But if you say, if I don't use that much, I only want 100 watts, 100 kilowatts. Just like when I pay garbage bill, I order big garbage can. I have one price. I have small garbage can. I have another price. Do you offer this to residential people? Because then theoretically, if you have a peak demand, okay, everybody changes to small capacity meters. Your peak demand will drop by 50%.
Right, and I should make
I've never heard this kind of option.
Well, let me correct it, and I'll give you an example. The size of the meter, most residential homes are limited to like 100 amps. So that comes out to about 5 or 10 kW. So you don't really pay more at the meter. The 200 kW was really sort of the entire building. That's like a large Home Depot or something like that. So currently, the only people that have smart meters are those customers that are larger In other words, they're 200 kW and above. And big megawatt, like one of these buildings here is a megawatt. So they would have, smart meters and stuff. Smaller customers, though, usually most homes have 50 amp or 30 amp or 100 amp service. So you're pretty much paying a flat meter service fee for that. However, in Europe, they charge you for the size of your meter panel. And that's a common thing. And it's a way to regulate. In France, the electric heating rate there, they give you 20 amp circuit breakers. And that's it. So if you go beyond 20 amps, you pop fuses. Well, during the heat storm in the summertime, which is a rare thing in Europe, everybody went out and bought portable air conditioners. And they were popping circuit breakers. So then they had to upsize their electric service, and they called Electricity de France. They got bigger circuit breakers, and they paid an extra so many euro per month. So that is one way to control usage. We don't have that system here. You pretty much can use as much as you want. You just pay more prices for it. But the service itself, the wires that go in, can handle up to 200 amps, for the most part. Where in Europe, they limit it.
As I recall, SCE has been experimenting with this kind of program since the early 80s. There are demand subscriptions, cycling of air conditioners, on and on and on. And the technology was never really a barrier, a major barrier. Do you think that metering is going to get anywhere without having true retail competition like in Texas, that under the current regulatory regime would really get the benefit of those meters?
I can't believe you remember demand subscription service. That was a long time ago. You're right. Utilities are always experimenting with different concepts, pricing programs, and so forth. And what happened in the early 80s with a very similar program, like critical peak pricing, was that all of a sudden we had more power than we could use. The crisis was not a problem. A lot of these programs started in 1979. By the mid-80s, everything was okay. So they sort of abandoned them. But now with the strategic plan, we said, we're going to do this for sure. Okay? So that's the first thing, is that there are cycles to innovation. And you're right, technology has never been a problem. We've always figured out a way to communicate. The way that we communicated with demand subscription service in 1979 was we used AM radios. Yeah, we went into the AM radio station, put a transmitter, so it was AM radio broadcast, pre-internet, pre-cell phones, and everything else. So we'll figure out a way. The second thing is that there is a behavioral issue associated with a lot of these different programs. It's getting the customers to respond to the pricing. And, that is the biggest barrier, I think, currently, to most of these. Did that answer your question?
Well, I was asking that, like in Texas, we have 50% of the load migrated to competitive energy providers.
Right. And that's the direct access. So
direct access, retail competition. And that's really what's pushing a lot of these programs.
Direct access works when there's a cheap source of power. And in California, which has always been constrained, we started direct access in 1996. And it was difficult to get a cheaper price than the utility. So the competition was constrained. And then, of course, there was the market manipulation in 2000, which killed it. And that was because, just like the stock market, there was the energy market. And it's always not so much about buying and selling. It's about the futures and the derivatives and the options that really kill you. So, there is a very complex financial component to making that work. And right now, there is some regulatory interest in resurrecting direct access for larger customers because of that opportunity. But for the smaller customers, it's still, I think, probably on hold.
Okay. Any more questions?
Following up on the critical peak pricing for industrial users, have you seen any evidence that industrial process or manufacturing plants have looked at critical peak pricing and said, this is a liability for me. I'm going to pick up stakes and go locate in a state with lots of coal-fired plants and see what they do.
Not so much. It is because usually they pass through their costs if it is an issue. And we haven't seen any migration of business. It's usually because of other issues besides electricity in California, with healthcare and insurance issues and taxes and things like that. But critical peak, it's not so much the punitive nature of it, it's what the options are and how you can deal with it. We didn't have automatic technology 4 years ago when we tried to roll out critical peak pricing. Now we do. Now we can make the buildings smart. PG&E has dozens of buildings that are on critical peak that automatically sense the price signal and automatically dim the lights and adjust the air conditioning. So when you have options and solutions to the system, then that's why we've resurrected it again. What I've seen is, for example, large energy-intensive businesses tend to locate themselves in low-price jurisdictions. There is no Disneyland theme park in an investor-owned utility. Microsoft is in a public power agency up in Washington, where electricity is cheap. So when you have a large portion of your business driven by electricity, then you tend to go where it's cheaper, as opposed to the dynamics.
Great. Thank
Okay.
you very much.
All right, thank you. Just one quick thing here. Wanted to show the thermostat, and this is the research that was being done. The normal thermostat, the energy efficient thermostat, the thermostat with the programming, and the critical peak thermostat. So, you know, there is one technology that's here today that UC Berkeley helped develop. It's in the Home Depot stores now, and it is a smart thermostat. And if there's any example of a technology that benefited from research and the communication between industry and academics, it's the thermostats in the Home Depot. So with that sort of example of a success case, I think there's a lot more opportunity for future innovation. It can get it from the meter, it can get it from FM radio stations, it can get it from pretty much anywhere depending on what chip you put into it. In SMUD, they use FM carrier, like you see the ID, and also in PG&E, it will be, I forget what, but SCE will be Zigbee. So you just buy out the chip, your Edison, pop your chip in, and you're good to go. Well, the thing about it is that it's not mandatory, you know? Don't put a chip in if you don't want to, but look at all the savings you're missing out on. You know?
But how do we know because it'll turn itself on because you pay a super high rate, but if it can't tell you that it's paying a super high rate, and you basically circumvent the system?
Well, you can, but the thing is that you don't have to join the rate either. This is all optional and it's all voluntary. So, you know, other delivery channel we found is word of mouth, is that when people start talking to each other, I mean, how do you think cell phones migrated so quickly? Microwaves, all these other technologies, the adoption rates. It's people talking to people. Come over and see this new color TV that I installed in my house. I'm the first on the block. Before you know it, they're all being sold. Okay, thank you.